All right, so here we go. I need the variables first. So I'll double click here. What are the two variables in data set 1?
Volume and pressure.
Okay, volume. That's V for volume. I'll make capital V as the symbol. What are the units for volume, please?
Meters cubed.
Okay, so M. And then if you notice, Logopro has some cool features over here. I think there's a superscript cubed. Did you guys see how I got to that? It's right there. L, you'll find that useful. So I'm done. And what was the other variable, please?
Pressure.
Pressure.
P.
Okay. So pressure. Look good so far? Pressure. P units, please.
PA. Capital P.
So I think that stands for Pascal.
Yeah, Pascal.
Blaise Pascal. Whatever he did, right? So that's a person. Typically in physics, the units are named after people who did something interesting in physics. Like Newton, Pascal's. You'll see as we go throughout the year. I'll hit done. Little loud out there. So I'll need one person to read me these numbers for volume, please. And I'm going to use the arrows to navigate. You see how the arrows move to different cells on my spreadsheet? Okay, so volumes, please.
0.100.
0.1. What else?
0.5.
0.5. What else?
1.
1. What else?
2.1.
2.1. What else?
4.
Well, hold on. 4. What else?
4.99.
4.99. What else?
8.
8. What else?
9.98.
9.98. All right, anything else? All right, now I'm going to go back up to the top again. Now, I'm going to read me the pressures, please, from top to bottom.
40.
40.
8.07.
8.07.
4.
4.
2.
2.
1.01.
1.01.
0.8.
0.8.
0.5.
0.5.
0.4.
0.4. All right. So I've made this graph. Now, I've sort of like jumped the gun a little bit. Let's step back for a moment and let's just talk about why the hell are we doing this? Okay? So just look towards me for a moment. Think about the class as a whole. We studied what kind of motion?
Constant velocity.
Constant velocity, right? Okay. So, constant velocity motion. So what do you think we're going to study next? If the class actually makes sense. Go. Okay, simple words, you mean what? Is the velocity going to be constant? Okay, so I agree with you. So we're going to do something where the velocity is changing. Now, I ask again, different question. If we wanted to take you step by step, that is, I don't want to change too many things. I want to change only one thing about the motion. I can change the velocity two ways. I can change the direction something goes, or I can change the... Which would be the simplest? Everybody yell it out.
Speed.
Yeah. We're going to not change the direction of motion yet, but we're going to have an object do what then?
Slow down or speed up.
Okay, slowing down happens to be a little more complicated in the physics than speeding up. So we're going to start you with what?
Speed up.
So now you know what we're going to do, right?
Yeah.
Okay, stay with me here for a moment. When we did position time graphs, what did our position time graph look like? What shape? Do you think when we change speeds for an object, the object will have a straight line position time graph?
Curveball.
Okay, now you may turn the other sheet over and look at it. Do you understand why we're giving you this?
Yeah.
Okay, now, let me say one more thing really quick. I don't assume that you know how to make an equation when we have a curve. I assume, basically, you know Algebra 1. And in honors, you know Algebra 1 really well. You know how to do y equals mx plus b. You see equation up on the board, vertical variable equals slope times horizontal variable plus vertical intercept. I am assuming you know that, and that's it. And we need to make an equation for not just lines, but also, and this is why I'm teaching you this now. You guys did. Okay? So I'm giving you different curves you will encounter in physics. And by the way, this is about it. What you see there on the sheet, what is there only, how many different shapes do you see? 7. Okay, there's a certain beauty in the fact that 5 shapes represent how nature talks to us throughout the year. There's some beauty in that simplicity. Make sense? And that's what's going to happen throughout the year. One of those curves or one of those shapes will happen every lap. Make sense?
Yeah.
Nothing else. All right. So if I look at this graph, I have this curve. Now I'm hiding some of my data, and I like any color you want, and as long as it's black. So I'm going to choose black there. And I'm going to move this guy down a little. I'm going to move this guy down a little. Okay? So now I can clearly see. Pause. Which curve do you think fits this particular data?
3.
Okay, the third one down. Okay. What does this imply mathematically? If you see a curve like this, notice. I should go to Smartboard for a minute. This shape implies that, what is it? Pressure is proportional to what?
Inversely.
I'm hearing it. So
Inverse
yeah,
exponential.
this shape implies that pressure is inversely proportional to volume. That's a fancy way of saying it. It's basically saying that P is directly proportional to 1 over V. Are you guys with me?
Yes.
Okay. Now, there is a statement that says which variable I want on the vertical axis. It says on the worksheet that we want the first variable on the vertical axis. Do you guys see that? Note that when making a graph, the first variable is graphed on the vertical axis. So I already screwed up, right?
Yep.
I wanted volume here. Well, it's so hard to fix. What a bummer. I'll just click there. Are you guys good now?
Yeah.
You're all happy? So I just fixed it. Now, and this graph looks like an inverse relationship. So what we do in science, this point, is we say, all right, if we are correct, you got to hear the logic here now. If indeed this is an inverse relationship, then volume will be proportional to 1 over pressure, right? So we test that idea. Let me say this again, because you've never done this before. When we see a curve and we think we know what its mathematical relationship is, we test that relationship. For example, here, it sure looks like V is proportional to 1 over P. So what do? Let's graph V versus, not V versus P, we already got that. We want to graph what? So we want to graph V versus 1 over P. Good. And if it's correct, if that is the true relationship between the variables, what shape will we get?
In line.
These people are starting to get it.
No.
So you're right. So here's how you do this with Logger Pro. It's quite easy. You go up to the top, you go Data, New Calculated Column. You're going to have to remember that. Okay? This is how you tell Logger Pro how to make a new column. Once you have a new column, that column will appear here, and one of our choices on this axis will be 1 over pressure. Instead of just pressure, we will have a third option here. So once we create a new column, we will have another option on what to graph. Are you guys following me?
Yeah.
So data, new calculated column. What does this new column need to be? Again, we want to graph volume versus 1 over pressure. So we need a column that is 1 divided by, how about everybody?
Pressure.
Good. And then 1 over P, is that good? And then here's a tricky part people mess up. The units then become 1 over,
Pascal.
yes. So we got 1 over pascals now. And then, oh, by the way, you can use the tab button. If I click here and I press tab, I go to the next one. I press tab, I go to the next one. It's just easier. It's quicker. Now this window where it says expression is where we tell the computer how to calculate our new column. What are we going to tell it to do? What are we going to tell it to calculate? I can almost hear you guys. It needs to be a lot louder. The computer can't hear you.
1 over pressure.
Okay, so 1 slash, now this is the important part. You have to choose pressure from here. You don't just write pressure. The computer says, see how it puts it in quotes? It's saying take this whole column. Take every number there. Instead of 40, the computer's going to go 1 divided by 40. Instead of, I don't know, 8.07, the computer's going to do 1 over that. You following me?
Yeah.
This is how all spreadsheets work. This is why they're so powerful. So I hit done. Watch what happens. Do you see my nice new column?
Yeah.
So in the blink of an eye, it did what would have taken me like half an hour with a calculator. Okay, now I'm going to see what I just did up there so I can actually see all my data. Because there's a third column, the computer hides it. I don't like it hiding things. So I've expanded, I've shrunk down my graph a little bit, and I don't even want to hide my original graph. So I'm going to copy and paste. See, I'm going to do Apple C, then I'm going to do Apple V. Now I have 2 graphs there, you just can't see them. I'm going to do Apple R. Do you see the 2 graphs now? So I just copied it, literally. Copy, paste. And I have a new graph, except these graphs are identical. So I'm going to change the lower one to what?
1 over P.
Bam. Now, if that was the mathematical relationship, if we were correct, what shape will that graph be?
Line.
Good.
Line.
All right. Let's see what we got. Is it a line? Okay. So it looks pretty good. Now, could we put a best fit line on that? Okay. So it looks like my graphs need to be scaled a little bit. So I'm going to scale them a little bit. I'm going to play around with make them look cute. All right. Now I'm going to take this one and scale it a little better. Now I'm going to make it look cute. All right. How's that look?
Okay.
All right. So now you would want to write an equation. I'm almost out of time in the screencast. So I'm going to write the equation really quick,
Run, Mr.
and then we'll stop the screencast. So I'll write volume equals, help me, 4 meters cubed over 1 over Pascal. Why don't I just write Pascal here? Because it's 1 over Pascal. Okay? And then that's times pressure. I screwed up. See if you can find the error. Plus 0.03. And then the units are meters cubed because that's my intercept. Now where did I screw up? This is a common error. Yes?
You put Pascal as an exponent when it should be,
Yeah.
no?
Let me just show you before I run out of time. I got 30 seconds. Go.
Should it be meters cubed over Pascal?
Go. It's meters cubed over 1 over Pascal. Nice try. If you take this, this is not what was on this axis. That's a really common error. Now, I ask you, is this a graph of the curve? I mean, is this equation the curve, or is this equation the line?
Line.
Ha! It's both.
2.
Okay, it's both.